everyone, welcome back to the channel. So coming back to the topic, that is operating system deadlocks. So in previous lectures we have already discussed the deadlock introduction, deadlock avoidance technique along with some algorithms like Banker's algorithm. Also we have discussed all about safe and unsafe states along with some important MCQs. So now in this lecture we will be discussing about deadlock prevention introduction as well as its algorithms. So this lecture is very important for all students who are preparing for their college level examinations as well as their competitive examinations. So let's start with the introduction. So students, remember one point: deadlock prevention is nothing but it is one of the most important schemes that is internally used in every operating system, right? So deadlock prevention can be done eliminating just by eliminating any of the four necessary conditions. We have already discussed about four necessary conditions that include mutual exclusion. We have discussed everything in detail. Second is hold and wait. Third important condition is no preemption. And fourth condition is circular wait. Okay, so these are four necessary conditions of deadlock, and in case of deadlock prevention we can prevent deadlock by just eliminating any of the four conditions. Okay, for example, if you control no preemption scheme, then it is a possibility to control the deadlock. हमने हमेशा से ये डिस्कस किया है कि डेडलॉक होता है जब ये चार कंडीशंस अकर होती हैं। अगर इन चार कंडीशंस में से एक को भी कंट्रोल कर दिया जाए तो वी कैन इजीली अवॉइड और वी कैन इजीली प्रिवेंट द डेडलॉक इन एनी ऑफ द ऑपरेटिंग सिस्टम्स। Okay, in deadlock prevention the request for resources is not always granted if the resulting state is safe. All right, so this is the definition of deadlock avoidance technique. Now let's just move to the deadlock prevention introduction. Remember one thing: the possibility of deadlock is excluded before making any request by eliminating one of the necessary condition is called deadlock prevention. This is the general statement जो कि हर साल हर बार एग्जामिनेशन में आती है. Second statement is deadlocks can be prevented, जिससे हम इंश्योर करते हैं कि ये चार कंडीशंस कभी भी एक साथ अकर ना हो. Here the request for a resource may not be granted if the resulting state is safe. Okay, deadlock, very important statement I am going to share. Deadlock can be prevented if the resources are numbered uniquely. Okay, if we allow our operating system to give numbers to every resource, like one resource is CPU numbered as 1, second resource is memory numbered as 2, if we allow our operating system to give unique numbers to every resource, then we can easily prevent the deadlock. Okay, and processes are allowed to request for resources only in the decreasing or increasing order. Okay, increasing or decreasing order or increasing or decreasing resource numbers. I'm repeating the statement: deadlock can be prevented if the resources are numbered uniquely and processes are allowed to request for the resources only in decreasing or increasing resource number. All right, so it will help in violating circular condition for deadlock. If one person or any operating system follow these two rules, with the help of these two rules we can easily violate the circular wait condition. Okay. And here is one more important statement that says deadlock prevention is more restrictive than deadlock avoidance. So deadlock avoidance has less restrictions, because in avoidance we just need to check two important points, that is safe and unsafe state. सिर्फ दो स्टेटमेंट्स आपको चेक करनी है अगर जब हम डेडलॉक अवॉइडेंस की बात करते हैं, जस्ट चेक अबाउट सेफ और अनसेफ स्टेट। सो इसीलिए इसमें कम रिस्ट्रिक्शंस होती हैं। लेकिन डेडलॉक अवॉइडेंस में हमें 4 कंडीशंस में से किसी एक कंडीशन को कंट्रोल करना है। कैसे कंट्रोल करना है, क्या मेथड वी हैव टू यूज, वो सब चीजें हमें चेक करनी है, तो इसीलिए वो ज्यादा रिस्ट्रिक्टिव होता है। नाउ लेट्स जस्ट मूव टू इंपॉर्टेंट क्वेश्चंस। First question says which of the following is not a valid deadlock prevention scheme? बहुत से कॉम्पिटेटिव एग्जाम्स में ये क्वेश्चन आया है। ओके, सो प्रिवेंशन में रिलीज ऑल रिसोर्सेज बिफोर रिक्वेस्टिंग अ न्यू रिसोर्स, दिस इज द करेक्ट स्टेटमेंट अबाउट डेडलॉक प्रिवेंशन, बट वी हैव टू सेलेक्ट द नॉट वैलिड कंडीशन। ओके, मान लीजिए प्रोसेस P1 ने रिसोर्स R1 को और रिसोर्स R2 को होल्ड करके रखा है और करंटली इट इज यूजिंग रिसोर्स R3। सो ऐसे में ये क्या करेगा, सभी रिसोर्सेस को जब रिलीज कर देगा, ठीक है, ये दो रिसोर्सेस को मान लीजिए ये अभी यूज कर रहा है एंड इसका वेट कर रहा है, तो जब P1 R1 और R3 को कंप्लीटली रिलीज कर देगा, तभी वो R2 के लिए यानी कि नेक्स्ट रिसोर्स के लिए रिक्वेस्ट कर पाएगा। तो इससे हम प्रिवेंशन को कंट्रोल कर सकते हैं। इससे क्या होगा, ये कंडीशन जो है ये डायरेक्टली सर्कुलर वेट का डायरेक्ट डेफिनेशन है। नंबर ऑफ रिसोर्सेज यूनिकली and never request a lower numbered resource than the last one requested. This is the correct statement I have already shared with you. If we give unique numbers to every resource and arrange them in ascending or descending order, only then we can prevent the deadlock. Next is never request a resource after releasing any resource. Okay, so this statement is not correct. Never request a resource after releasing any resource. It says if process P1 is using resource R1, ये बोलता है कि जब वो R1 को रिलीज कर देगा उसके बाद वो R2 के लिए रिक्वेस्ट नहीं कर पाएगा, बट ऐसा नहीं है। अभी हमने ऑप्शन नंबर 1 में यही चीज को देखा था। ऑप्शन नंबर 4 सेज रिक्वेस्ट and all required resources will be allocated before execution. Okay, so this statement is also correct. So correct answer यहाँ पर क्या होगा, according to not, correct answer will be option number 3. Okay everyone, I hope everything is clear till now. Next question is which of the following is are not true about the deadlock scheme? Not true, that means we have to check the false statement. In deadlock avoidance, number the resource uniquely and never request a lower numbered resource. So what is the false statement? This is the false statement. Why? Because this is not the definition of deadlock avoidance. This is the definition of deadlock prevention. Okay. Second says in deadlock avoidance, the request for the resources is always granted if resulting state is safe. We have already discussed whenever there is any statement which says about safe or unsafe state, then directly go for deadlock avoidance. So this is the correct option. Option 3 says in deadlock prevention, never request a resource after releasing any resource. We have already discussed this statement in this question. So this is also false statement. So we have to check the false statement, that is option number 1 and 3. Okay, so this is all about deadlock prevention. We have already discussed deadlock avoidance as well as Banker's algorithm. That was very important question, very important topic related to deadlock. So now in the next lecture we will discuss some most important and most repeated MCQs for your college level examination as well as your competitive examination. So if you like the session, please comment below to motivate me. Thank you so much and